quotation, a product image, and a broad torque claim are not enough to approve a helical gear reducer supplier. The real risk lies in the gaps between design, material, heat treatment, machining, assembly, testing, shipment, and warranty. If those stages cannot be connected to the exact unit being purchased, a professional-looking offer may still lead to poor fit, an incorrect shipment, or limited recourse after installation. Start with supplier identity. Request legal registration details, the factory address, manufacturing scope, and clear contact information. Confirm whether the quoted company manufactures the reducer or acts as a reseller, and identify the party responsible for warranty obligations. Names should remain consistent across catalogs, drawings, certificates, invoices, and shipping documents. Inconsistent entities weaken traceability and make later claims harder to resolve. Next, establish technical fit. Request a configuration-specific datasheet, model table, and approved dimensional drawing. The drawing should define the overall envelope, shaft diameter, keyway, flange, mounting feet, center height, bolt pattern, input arrangement, and rotation information. For a customized reducer, it should also identify which interfaces are approved, which details remain provisional, and which revision controls production. Motor data must be documented with equal care. Confirm power, voltage, frequency, speed, frame, protection class where relevant, and any special electrical requirements. A reducer may fit mechanically yet remain unusable because its motor is incompatible with the site supply or control system. The selected rating also needs a documented basis. Ask for a readable selection or calculation summary covering ratio, output speed, continuous torque, service factor, duty cycle, starts, ambient conditions, mounting position, driven equipment, and lubrication requirements. For continuous duty, high torque, variable load, or severe starting applications, thermal assumptions should be stated rather than hidden behind a model code. Material evidence forms the third layer. Request certificates for critical steels and castings, together with heat treatment and hardness records for the gears. These documents should identify the relevant batch or component. Published statements about alloy steel, hardness, case depth, or precision grinding are useful as request points, but they do not prove the condition of the ordered reducer. Manufacturing and inspection records provide the fourth layer. Depending on the purchase agreement, reports may cover gear dimensions, shaft geometry, bearing fits, assembly settings, no-load running, noise or vibration checks, oil leakage, and final visual inspection. Each report should identify the unit or batch, the checks performed, the acceptance criteria, the results, and the final release status. Traceability must connect these records. A serial number or batch identifier should link the approved drawing, inspection report, delivery note, and warranty file. Without that connection, even a detailed test report may belong to another configuration. Delivery control is the fifth layer. Request packing specifications and shipment records showing how the reducer will be protected, particularly for export handling. The purchase order should preserve the complete technical identity: model, ratio, motor, mounting arrangement, shaft, flange, drawing revision, quantity, destination, packing requirements, inspection requirements, and agreed hold points. Finally, obtain written warranty terms. Confirm what is covered, what is excluded, what evidence is required for a claim, and which operating limits formed the basis of supplier approval. If incorrect selection or operation outside stated limits is excluded, those limits must be documented before shipment. For high-risk orders, define hold points for drawing approval, material review, first article inspection, running tests, and packing release. Also require controlled notification of changes to bearings, motors, castings, treatment routes, or drawing details. Approval should follow one coherent evidence chain: supplier identity, technical fit, material proof, inspection, traceability, and delivery, then warranty accountability. The objective is not more paperwork. It is a defensible decision tied to the exact reducer that will become part of the production system.